In this video, we're going to talk about how to identify outliers in a data set. So here we have a data set of the ages of people at an Incubus concert at Xfinity Theater. This is only 100 data points, so it's not everyone at the concert. And what we're going to do is we're going to find the 5-number summary for this data. So this is a good review for finding the 5-number summary. We have our min. We have our quartile dot inc. Takes 2 arguments, the data and which quartile you want. We have the median. We have quartile 3. And we have our max. We're going to find our IQR, our interquartile range, by taking Q3 and subtracting Q1 from it. And now here's where we can use the IQR to identify outliers. Now we're going to do this when we have a data set where we're using the median as the measure of center, which would typically be a data set that is skewed. This data set isn't skewed, but we're still going to use 1.5 IQR rule just to show you what it looks like. So it's called the 1.5 IQR rule because we're going to take our IQR and multiply it by 1.5. And when I do that, that's going to give me this value times 1.5 is 1.5 IQRs. Now we use the 1.5 IQR to find a lower fence and an upper fence. And this lower and upper fence gives us an idea of which data are regular data points and which data are the data that are outside of this fence, so smaller than the lower fence and bigger than the upper fence. Those are going to be considered outliers in our data. So if I take Q1 and I subtract from it 1.5 IQR, I get a value of 29.875. So anybody 29 or younger at this concert would be considered an outlier. And to find the upper fence, I take Q3 and I add 1.5 IQR. So we're adding 1.5 IQR to Q3 and we're subtracting 1.5 IQR from Q1. And that gives us our upper and lower fence. So anyone 51 years of age and older are also going to be outliers for this data of people going to an Incubus concert. Now, what I can do here is I can do some conditional highlighting. So I'm just going to highlight my original data. And over here we have conditional formatting. So I'm going to create a rule, one that says that any values that are less than this value are going to highlight the cells that have values that are smaller than that in it. So when I hit that, you can see this 23 became highlighted. And here's another value, 18, that has become highlighted. We can do the same thing. We can highlight our original data. And we can add another rule, a greater than rule, where we're going to be greater than the upper fence. And that's going to add a couple more points. Here's a 62 and a 53. Now I can also just sort my data, which is always a good idea when I'm trying to find smallest and biggest values. And you can see that I have 2 values that are outliers that are on the low end, and I have 2 values that are outliers on the high end. And what I see is that 30 is the smallest value that's not an outlier, and I see that 45 is the largest value that's not an outlier. Now if I create a box and whisker plot using the built-in box and whisker plot feature, what you'll see is we have 2 outliers up here and 2 down here. And my lower whisker starts at 30. That's this value right here. And my upper whisker ends at 45, which is this value here. So the whiskers no longer go to the min and the max. They go to the value that's the smallest value that's not an outlier and the biggest value that is not an outlier. And then our outliers finish out the graph. So again, whenever making a box and whisker plot, we would like to have all our values taken into account with the least amount of white space. So we go from 15 to 65. All right, change the chart title to Ages of People at an Incubus concert. And we're going to add a vertical label, and that's ages, and you can say in years. There we go. So now, what if my data were symmetric? Well, let's find the mean and the standard deviation for this data set. So the mean I find using average. And this is a sample, it's not everybody at the concert. So that's going to be stdev.s. And again, all these people. Okay. So you can see that the mean and the median are really close together, which tells me that this is probably symmetric data. The standard deviation is pretty small, which tells me the mean is probably a reliable measure of center. You can even see right on this plot that the mean is right next to the median. Okay, they're basically the same value. So this data set's actually symmetric. It might even be bell-shaped. Let's take a quick look at our histogram. Of course, we're going to use not the built-in feature, but that looks pretty good. That's pretty bell-shaped right there. But even if I decide not to use the auto, because we always don't want to use the auto, all right, looks the same. It didn't really change anything. All right, it's pretty symmetric. I don't know that it would be bell-shaped. We'd have to go through and find how many data points are within 1, 2, and 3 standard deviations of the mean. And we could do that. But we're not going to do that in this video. Let's just assume that this was approximately normally distributed. What I can do is I can actually calculate something called the z-scores for the ages of people at an Incubus concert. And what a z-score does is it's basically a number that tells you how many standard deviations away from the mean it is. So to calculate a z-score, we take a data value from the data set, we subtract the mean from it, because that's how far this data point is from the mean. Ooh. Okay. So this expression right here, A2 minus G2, is just how far the data point is from the mean. Now I want to know how many standard deviations it is. So if I divide by the standard deviation, I'll know how many standard deviations this point is from the mean. Now if I want to do this for all the points, I always want the mean to be the mean, so that's going to stay constant, and the standard deviation's also going to stay constant. So I've just found how many standard deviations this value is from the mean, and you can see that it's 4.5 standard deviations below the mean. That's why it's negative. Now if I copy this formula down by double-clicking here in the corner, you can see that my other outlier is 3.5 standard deviations below the mean, whereas all my other data points are about 2 or 1 or less than 1 standard deviation away from the mean. And when we get to the bottom half, this outlier, using the 1.5 IQR rule, is only 2.6 standard deviations from the mean, but the other one's 4.5 standard deviations from the mean. And so what we talked about in the previous video is that in general, if you're more than 3 standard deviations away from the mean, then you're probably an outlier. Since this one is not quite 3 standard deviations, if we were using that method, this 53 might still be considered a regular data point and not an outlier. Which that point, 53, right? 53 is not that far from the upper fence. So in one strategy, one method, we got an outlier, the other method we didn't. But you can use these z-scores to also show whether you have an outlier or not. All right, well, that's all for this video, and I'll see you in the next one.